Hello, and welcome back everyone to another video on Discovering Code channel. आज हम करने वाले हैं कोड फोर्सेस का प्रॉब्लम स्ट्रेंज पार्टीशंस. ये प्रॉब्लम CP-31 फ्रॉम TLE एलिमिनेटर्स की शीट में भी है in the 900 series. So let's get started, and let me just go to the laser. You are given an array of array A of length n and an integer x. Okay, you can perform the following operations as many times as you would like, possibly zero. Okay, replace two adjacent elements of the element sorry replace two adjacent elements of the array by their sum. So if you're given like 1 and 2, we can replace them by 3. uh is it both the places or like just once? Okay, so from here we can see 6 and 9 is replaced by 15. So the array shortens. So let's type it out actually. Let me make this white. Right. So operation can be performed many times, 0 to INF. Operation 1 is replace adjacent elements by their sum in the array. And the second one is, for example, if the initial array is 369 in a single operation, one can replace the last two elements by their sum, yielding an array of 3, 15. Or replace the first two elements to get an array 9, 9. Note that the size of the array decreases after each operations, which is implied actually. The beauty of an array is b is equals to b1 till bk is defined as from I equals 1 to k bi by x. So what is this x? We are given that x. So bi, which is after performing this operations, I assume, which means that we divide each element by x and round it up to the nearest integer and sum up the resulting values. For example, if x is equals to 3, why does it reset every single time? If x is equals to 3, then the array is 4 comma 11 comma 6, then the beauty of the array is equals to 4 by 3, 11 by 3, and 6 by 3. 4 by 3 is not divisible. It will give us something like 1 point something. So we will round it up, right? Round it up to the nearest, which is 2. And then similarly, when we divide this by 3, we'll get 3 point something. So we round it up to 4. And then similarly, in the last case, it's fully divisible. So we get this and we sum it up, we get a 6. Sorry, we get a 8, my bad. And please determine the minimum and maximum beauty you can get by performing some operations. Please determine the minimum and maximum beauty you can get by performing some operations on the original array. Okay. All right. Okay. So before thinking about this problem, let me just do a quick analysis on the time complexity that we are permissible to use. All right. So I think we don't have, we just have this rule. Now time complexity analysis. Oh, okay, sorry. Beauty of the array is calculated by each element divided by x, is calculated by sum of each element from I equals 0 till I equals why k was used, or to I equals n divided by x. So that is the beauty. We what do we need to find? Find minimum and maximum beauty you can get by performing some operations on the array. All right. All right, and we also have one more thing. Okay, time complexity analysis. So time limit per test is 1 second per test or test cases. So this is somewhere around 10 to the power 8. And how many test cases do we have? T is equals to 1,000, and n is, sorry, n is what? The next line contains two integers, n and x. N is the okay, n and x. Okay, there are three lines for input. We have the test cases line, then we have the n and x. N represents the array length, and x is the integer that we will be using to divide to find the beauty. So the array can go up to 10 to the power 5, which means the array can have 10 to the power 5 elements in it, and each of those particular elements can go up to 10 to the power 9. But it is a guarantee. We are given something that it is a guarantee that the sum of values of n, total sum, does not exceed 10 to the power 5. N is 10 to the power 5. Sum of n elements is less than equal to 10 to the power 5. Okay, so sum is less than 10 to the power 5. So I think we could go ahead with a O of n solution. Anything above that, we can't really do anything. But I think we can go with an O of n solution. If we see 10 to the power 5, if we iterate over each array, and the worst case is 10 to the power 5, then this will be into 1000, which will be equal to 10 to the power 8, which I think is permissible. So we can go ahead with an O of n solution, I think. Okay. All right. So with that out of the way, but yeah, I think we will, for any intermediary, okay, the sum does not exceed 10 to the power 5. So we can store it in an array, integer. So that is also a clue that we can use an integer for all of the variable storage that we would be requiring. All right. Okay, so now we jump into this problem solving aspect of this problem. So what I'm gonna do is I'm gonna take the first test case that we have. So we are having two test cases, right? So I'll pick up the first one, which is 3, n is equals to 3, x is equals to 3, and then the array is 3, 6, 9. So we had this. All right. Mm, I think all of them are divisible by 3, as we can see. This will give us 1, this will give us 2, this will give us 3. Sum them all up, we get a 6. So the minimum is 6 and the maximum is 6. If we add these up, then we'll get a 9 comma 9. If we add those up, we get a 9 comma 9. uh, for this also we'll get a 3 3 3 3. So this gives us a 6, this gives us a 6. If we add these up as well, then we'll get a 18. Add those up as well, we get a 18. If I divide this by 3, we'll also get a, sorry, if we divide this by 3, then we'll get a 6 directly. So in any test case, in any scenario, even if we do any number of operations, we will always get a 6. So what does that tell us? That tells us a very important clue, that if the whole array is divisible by x and we don't have to round it up, uh, we directly get some kind of value, then that means that whatever answer we get will be the final answer. It will always be the minimum and the maximum beauty that we can achieve. Uh, I think so, but I need to test it on something else as well. So you know what? Let's test it on 2, 4, and 6, shall we? And our x will be 2. So let's see. This gives us 1, this gives us 2, this gives us 3. Right? If we sum it all up, we get a 6. If we do 10 comma 6, then what do we get? This gives us a 5 and this gives us a 3, right? Oh, okay, we get a 8. Okay, so this is 8. If we sum these two up, we get 2 comma 10. Oh, sorry, my bad. I'm so bad at math. What am I doing? Uh, yeah, 2 plus 4 is 6, guys, and not 10, like my dumbass thought. But we get a 6. We get a 6. So 6 gives us 6. 6 by 2 gives us 3, and 6 by 2 gives us 3. And 3 plus 3 is 6 and not 8. And so I think my theory is kind of correct. But let's take an example to 18, and then let's take something like 12. All right, let's jumble it up. X is 2 again. So what I'm doing is I'm trying to brainstorm through different test cases to see if my theory about uh, if X wholly divides all the elements, then whatever beauty of the array we get is the minimum and the maximum that we can get even after doing all the operations. So I'm just trying to validate that theory by taking up some basic test cases. Let's see. So x by 2, this gives us 1, this gives us 9, this gives us 6. So the beauty becomes 10 plus 6, 16. If we add these up, we get 20. If we don't add that up, then we get this array. If we add these two, then we divide, then we get 10, and then we get 6, right? Yeah, 16 again. And if we add these two up, then we get this is 2, this is 20, 30. This is 30. So we get a 2. 2 by 2 is 1, and 30 by 2 is what? What is 30 by 2, bro? 15. And 15 plus 1 is 16. So I think that is the case. After going through all this, I'm pretty sure that what this test case is telling us is that the minimum and the maximum will be the same for when the x wholly divides the whole array. And so we can frame our answer. We can pass like many test cases where if the whole array is divisible by x, then whatever the beauty is of the current one is the minimum and the maximum. So yeah, that's part of the solution. Let me just pause and let me just clean this up. All right, cleaning done. Oh shit, my bad. Ayo, it doesn't come back. Thank God. Okay, so let's write solution. Observation 1 is x y due to some some all right, and if the x does not divide, then what can we do? How can we find the minimum and the maximum? Hmm. If we want to find, if we want to minimize something, what do we do? Hmm. We pick the smallest two elements, right? Uh, dun, dun, dun. Okay, wait. We'll have to think in terms of division here. If we have 100, if we divide by 2, we get 50. So like half of it is gone. But if we divide it by 4, okay. The bigger the x, the bigger the division. That is basic child stuff. I don't know what I'm saying. What is the relation between these two? Uh, all right. Think. So the I think the basic beauty is whatever array we get, we generally just divide it by x and we find the initial beauty, let's say. Now we can't say for sure that that will be the minimum beauty. I think it will be, right? Because if we do any kind of operations on it, um, then there's a good possibility that that added sum will yield something bigger. But I don't know. I'm not basing that theory on anything. I'm just speculating here. Mm, let me think, right? Let me think. Mm, hmm. So I think let's think about this, right? If we have an initial state, I was looking at this second one. So we got the min as 7 and then the max at 8, right? 6, 4, 11. Now if we add any of these two elements, let's say we add this, we get 10 and 11, right? And if we divide by 3, then we'll get a 3 and a 3. Sorry. Mm, right, we'll get a 3 and a 3, right? No. Uh, sorry, we get 3 point something, so this becomes 4. And then we'll get 3 point something again, so this becomes a 4 again. So this will become 8, which is our max. But to get a min, oh wait a second. 6 plus 4, we get a 10, we get 11, right? We want this 7 to appear. So if we add it again, we get a 21. Now 21 divisible by 3 gives us 7. That's our min. Uh, if we divide at this stage, we'll get 8. But I think if we divide at this stage as well, uh, so this gives us 3, this gives us 4, this gives us 4 again, right? No, wait. This gives us 2. This gives us 2, this gives us 3, this gives us 4. 4 plus 3 is 7 plus 2 is what? Oh, sorry. 3 into 2 is 6. My bad. Okay, so yeah, 2 plus 2 plus 4 gives us 8. So yeah. Can we see a pattern here? If we look at the whole array and if we do the division by x at this stage, we will always get the max beauty. Because here I think we just got lucky, but when we start condensing the array into its simplest form, we might get the smallest beauty. Uh, because it just might be that the combination of numbers might uh, get divisible by the whole x. So mm, I'm not sure if I'm doing a really great job at explaining this, but if x divides all the elements perfectly, like we said here, then the max and the min of that is equal. But in observation 2, as we just saw, whatever the max will be the initial state itself. And if we do the total of the sum and then divide it by x, then we'll get the minimum. Now, it could be that the minimum can match the maximum, or but if we condense or merge numbers, it will never be more than the max beauty that we got, right? Because it could never, it's just a formation from those numbers that we had initially. And so it will never be more than that. It could be equal to it, it could be less than it, most probably, but it will never be more than the max beauty. So I think that kind of makes sense, but all right. Uh, I'll try and okay, let me just do this and I will start writing the code after this. Actually, it's done. There you go, there you go, there you go. Great. Now we'll write a second one. Second observation. Observation 2. Observation. Wow. My English. Observation. Okay. If our sorry, the max beauty would be attained from the initial setup of the array, min which could be equal to or less, but never but never more than the max, can be attained by summing all elements. Or actually, we could possibly also do checks in intermediary steps. But from this example, I'm getting that we could just directly add them all up and check. If we don't get it then we won't probably get it in the intermediary steps as well. Yeah, so by summing all elements and dividing by x. So with these two observations in mind, let us get on with the execution. So here we have the solve function. There we go. Now the first input we have already resolved the t number of test cases. Second will have n and then an x value, and then we'll have a range of elements to take into our array, imaginary, not so imaginary anymore. Array of I is equals to f around extent. Great. All right. So if we can mean let's do a sum, or can we not at this exact time as all right, let's have int min, standard practice, and int max, initialized, and then I think we can we can directly calculate the maximum right here, can't we? I think we can, right? It's the sum of the uh, divi divisor, right? Uh, Let me go back to the Scally draw. 2 seconds, guys. Let me quickly do it again just to be sure. All right. So 3 ones are 3, twos are 3s are. So we are actually storing the divisor. Those are eyes, believe me. Okay. So max plus equals to array of I division x. But that will give us. All right, let me just do a very quick search. Sorry about that. Okay, so I think we should also add math.seal here. I don't even know if we had to do the observation one, but I mean, it was a good observation to have. But in code, I don't think we practically do require it. For some, we're gonna have to keep a very long amount because possibly 10 to the power 9. I mean, the problem did state that it will not go beyond 10 to the power 5, but still, just to be sure, we'll keep a long here, 64-bit integer, and then we can just go ahead. Actually, can I not do the sum here only in this loop? Why am I even... Wait a minute, why am I keeping an array from doing everything right here? Is that even required? Like, I don't think we really need to store this key element. Let's see what comes out from this, but it's good to try. It's good to try new things. That's how you learn. And what? I just wrote it down like 3 lines before this, after this, sorry. What was that? No, sorry, long sum. Yes. Long sum. Let's add an L for the aesthetics. And I think we can add the sum right here. Okay. Now, max is calculated like that. Long will be calculated on the sum. So then will be end of sum divided by x math.seal obviously on this as well, and then dot println. First we have to print the min, right? Yeah, min plus gap plus max is how we do it. Semicolon. I don't think if you're actually, we don't really kind of need to initialize this equals to 0. Wait. Why am I adding the, my god. Okay. Is equals to math.max of max comma this thing. It's doing a blunder right there. Math.max because it's the max element. What's wrong? Lousy conversion where to an int. Okay, yeah. I'll just add an int here. There you go. Beautiful. And same thing here. Math.min of the minimum value that we have and the seal that we might get from that. So, okay, integer dot max value. Okay, all right, let me just uncomment this, save this, run this. I've already added the, so let me just keep this here. There you go. Clear this from the previous, and the original output that we are expecting is this. I'll just put this right here. So this is the output that we are expecting. Let's run this. So we are getting a 3 instead of a 6 or an 8. Why is that? I think I'm doing way too much right here. Is that why? Min is correct, which is good to see, but the max is not, which is a bit of a concern. But max, okay, max is initialized with the min value. What are we doing? That is so wrong. Int max dot seal, take the element divided by x, and for each, since we're going through the whole array, I don't, and we're doing it on the initial as well. So why is it giving me a wrong answer? Oh my god, oh my god, oh my god. Wait. I think I'm doing something very dumb, which I should realize. I think for max I have to add it, each element sum. I have to add it like this, right? And I don't need a man.max here. I have to add it. Can't explain it. I can explain it. 6 and why am I getting a 6 instead of an 8? Max should be initialized with the first. I think I'm doing something very dumb, so I'm unable to catch. I think I've realized kind of my mistake that I'm doing everything on int, right? But mat.seal is used on a double and it expects a double. So I think somewhere in translation, uh, something wrong is going on. So let me just do one thing. Let me just shift everything to a double, and I'll just return the answer as in a as a as a Still getting 6. Let me just want this too long. Let me want this too long. What am I getting now? Still the same thing. I mean, okay. We're using the element. Let's take this as a double as well. And X as well. So going to double. I mean, I don't think my answer is wrong because it looks like a pretty straightforward solution. There you go. There you go. That's what I'm talking about. That's what I'm talking. Okay. All right. Let us try and submit this. I'm not sure if so much doubling, I mean typecasting is good for code forces, but we can try. All we can do is we can try. So yeah, let's try, because why not? We bring the site up and let me save this. Let me change this to main first, and then we have this. That's not where we have things. This is where we have things. Now we are going to use what's the name, strange partitions, submit. There we go, people. There we go, people. There you go. Please get to the accepted thingy. Please don't fail on the runtime at least. I mean, run test. Ow. Sorry about that. Test cases I can accept. Sorry about that. Wait a minute. Why is it still running on test case 1? What are we doing? I mean, there's something wrong, I guess. Still running on test case 1. It's gonna fail, I feel like. It's still running on test case 1. Is that a... Hello? Oh my god, bro, why does Code Forces do that? Okay, that passed, but look at the memory. That's a lot. Okay, guys, it did pass, but I do not like this kind of solution because a lot of typecasting is happening. I mean, I gotta figure out a way to understand this math seal function because stuff is getting lost in translation. That should not happen. And being a good programmer that I am, not being a good programmer in the sense that I know everything, but a good programmer, that means that I want to know everything. Does it make sense? Does it make sense? I don't know. Does it? No. Okay. All right, guys. I will see you in the next one. Until then, keep rocking and have a very lovely evening, morning, or afternoon. And I will see you in the next one. Goodbye.